In this example, we're going to sketch the graph of a basic cycle for this function. Our first step is find the amplitude. First step is amplitude, and we said that the amplitude is the absolute value of A, which in this case is the absolute value of 2, which is equal to 2. That tells me that the maximum value of this function is 2, and the minimum value is -2. Second step, find the period of this function. The period you find by taking 2 pi and dividing it over b. And in this case, b is equal to 3. So this is 2 pi thirds. This function has a period of 2 pi thirds. That means that one complete cycle takes 2 pi thirds. Okay? So that's how long that cycle is, 2 pi thirds. Number 3. Find the starting point. To find the starting point, we work with our angle. That includes a phase shift. So we take everything inside of this parentheses. Okay? 3x minus pi. And we equal it to 0, and we solve for x. So this would be 3x equal to pi if I add pi to both sides. And then we divide by 3 on both sides, and this gives you x is equal to pi thirds. This is where my cycle will start, at pi thirds. Now I found the starting point. Let's find the terminal point, and this should make sense. If I start at pi thirds and my function has a length of 2 pi thirds, then where does it terminate? Well, you take the starting point, you add the period, and that tells you where it stops or where it terminates. It doesn't stop. So my starting point is pi thirds plus the period, which is 2 pi thirds. That equals 3 pi thirds, which is equal to pi. Okay, so it will start at pi thirds and end at pi. Step number 5, I'm going to leave for later, and I'll explain it later, just because I want to show you another option. And this step 5 might be confusing for you. Okay, let's start plotting on our graph. I have a maximum value of 2. I'm going to do that here, 2. And -2 is the minimum value. My starting point is at pi thirds. I'm going to draw pi thirds here, skipping 1. So let's say this is pi thirds. If I skip again, this would be 2 pi thirds, and if I skip again, this would be 3 pi thirds, and 3 pi thirds is pi. So this is where I start my cycle, and this is where it ends at pi. Okay? Now, this is a cosine function, so let me review that function over here. The normal cosine function. Oh, these lines are so squiggly. I'm sorry about that. Here's cosine. Cosine starts at 1, if you remember. Cosine looks like a U shape. This is what it does, and this is -1. Let me do these dashed lines, see if it's neater. So it'll come down, hit the 0, hit the minimum value, and come back up. And it ends at a curve. And this begins at a curve, like that. Yes, like that. Okay? There's your cosine. That's a normal cosine. Okay? Notice that I have certain key values here. I have the value at 0. I have a 0 here. I have a value where I get my minimum. I have another 0 here, and I have a value where I hit the maximum again. So where it starts and where it ends, I can have 1, 2, 3, 4 different intervals for one cycle. So I know that in between my starting point and my ending point, I should have 4 intervals. So here's my first interval. Here's interval 2 from here to here. From here to here is interval 3, and from here to here is interval 4. There, I've divided my starting and ending point into 4 equal intervals, okay? what did these help me with? Well, from the starting point to the first interval, I know this is my first 0, this one here. This point here is where I'm going to hit my minimum value. And this point here is my next 0, this one here. And then my terminal point, which is where the graph ends, that's your last point. That's your pi for this function. So that's why these tick marks help me, because they're going to guide me through to sketching this graph as precise as I can. Okay, so let's do that. I'm going to draw some guidelines here because that'll help me sketch it, just so that I don't miss the maximum and the minimum points. Okay, so remember, cosine starts at the maximum value. Remember? Okay. And then it comes down. Well, this is my first mistake on this video. I'm not going to start here because we had said that the starting point is at pi thirds. So let me move over to pi thirds. That's where you see your shift. We're shifting over pi amount. So here's pi thirds. Here's my starting point, okay, at the maximum value. And now this first tick mark here, that tells me that's my 0. So I'm going to come down, hit my 0. This second tick mark, that's where I'm going to hit my minimum value, like that. This next tick mark, that's my next 0. And this last terminal point, that's where I end my graph. And that's how it should look. Not too bad. There it is. And there's the basic cycle for this function. Okay? Now, you can go ahead and draw 1, 2, 3, and another tick mark here, and continue. You can continue this graph. You can continue it, although it says one basic cycle. You can go ahead and continue both ways. Okay? 1, 2, 3, 4. And then you can do like that. And remember, these cycles repeat forever. And there you have it. So the strategy here is drawing one cycle, and then you can go towards both sides following the same pattern. On the previous video, on step number 5, I went ahead and I found out the distance between each interval. And I labeled these values on the x-axis. I don't think this is necessary unless you really want to know where that 0 is, but just for sketching to have an idea of the graph, I think you can go ahead and skip that step, but I'm going to go ahead and do it just in case. So if I want to know what these values are between the starting point and the, let's say this is the starting point and the terminal point, well, I would subtract the terminal point minus the starting point and divide that into 4 because I'm dividing it into 4 intervals. The terminal point we said was pi minus the starting point, which is pi thirds, and everything divided by 4. That equals 3 pi thirds, right? 1 is equal to 3 over 3. We need common denominators to subtract these two numbers. Everything divided by 4, that equals 3 pi thirds minus pi thirds. That gives you 2 pi thirds divided by 4. This is a 2. And that will equal 2 pi over 12, which is the same thing as pi over 6. So what does this number tell me? This number tells me that from the starting point here, let me grab red. From the starting point here to my next point on the x-axis, in between these two, there's pi 6. So if I want to find what this coordinate is exactly, I would have to take pi thirds and I would add pi 6. And before you do that, you need to find a common denominator and then add. So this would be 2 pi 6 plus pi 6, which is 3 pi 6, which is pi halves. So that tells me that this x coordinate here is pi over 2. Now if I want to know what this x coordinate is, I would have to take pi over 2 and add pi 6 again, because there's pi 6, the distance between these two intervals. Okay, so pi over 2 plus pi over 6, and that would equal 3 pi over 6 plus pi over 6, which is 4 pi over 6, which is 2 pi thirds. And that would be this x coordinate, 2 pi thirds. If I want to know this x coordinate, I would take 2 pi thirds and add pi over 6. 2 pi thirds plus pi over 6, that's the same thing as 4 pi 6 plus pi 6. I shouldn't have reduced it. That equals 5 pi over 6. So this coordinate here would be 5 pi over 6. And from 5 pi over 6 to pi, if I add pi over 6, again, I would get 6 pi over 6, which is pi. So this last step just helps you know exactly what this x coordinate is. I don't think you need to look for it in order to sketch this graph. This is a sketch, but it does help to divide your starting point and terminal point into 4 even intervals, just so that it helps you when you sketch the graph. It's nice and even, and you'll get a more precise graph. If you want to know precisely what these values are, then you need to know how to do step number 5. Okay, I hope this helps. And let me show you the graph in GeoGebra. And here it is. Here's the graph. And my starting point is about here. I came down at pi halves. Remember, we did figure this out in step 5. We got pi halves for my first 0. Then we had this minimum value. And then we have this value here, which was 5 pi over 6. And my maximum value at pi. And there's your cycle. And as you can see, this cycle you can continue repeating at equal intervals on both sides of the graphs. I hope this helps. I'll see you in the next video. We're going to do an example with reflection and using the sine function.